Hello everyone, welcome to this session. So in the previous sessions, we have already learned the structure of a neural network and the structure of a neuron, and what does a neuron do, right? So from this session, we will study the signal propagation in the neural network. So we start from the forward propagation. So let's consider there is a neural network. So we have in the input, we have input layer, we have two neurons, right? And the expected output here, we expect it to be 0.5. And the activation function in every neuron is a sigmoid, right? So, and also to make it simple to be demonstrated, I don't consider the bias in each neuron. So I think that each bias is 0 for simplicity. But in reality, this will be of different numbers. So let's see this neural network. So input layer have two neurons, and they are connected with the two neurons in the hidden layer. So as we can see, I1 connect to H1, and I1 also connect to H2. I2 connect to H1 and H2 also, right? So in the connection, there is a weight. So we can see this, for example, W1, I1 connect I1 with H1, the weight is 0.1. So the input to here from this root is the I value multiplied the W value. So it's the input of this root, right? So in each neuron, we have the activation function, but note that the input layer, this is different. So input layer, the activation function, it doesn't apply. Input layer is just to provide the input to the neural network, just the simple data input. So all the the hidden layers, the neurons here, and the neurons in the output layer, they have the activation function, and they receive input and provide output, right? So now we will show you the whole process about how to make the I1, I2 to this O1, right? So in this process, we use the following symbols. So I, that means, when I say I, it means values in the input neurons. So IO means that inputs to the output neurons. So IO is here, and O means outputs from the output neurons. So this is output from here. And IH means input to hidden neurons. So for example, this is the input to the hidden neuron. And H is the output from the hidden neurons, right? So you don't need to remember these symbols because they will appear in each slice. So now let's see that how can we calculate that. H1, right? We first calculate H1. So we first need to know that what is the input of the H1 in the hidden layer. The input, there are two roots. The first one is I1 multiply W1, so it's here. And another root is what? I2 multiply W3, right? So you can see here. There's a 0.9, 0.8, 0.35, 0.1. So we can have a result. So this is the input to the hidden neuron. So then we will go to the sigmoid function. The input will come here, right? So after the sigmoid the function calculation, we will have the H1 value. So H1 is the output from the hidden neuron. So this value will be propagated out from to here, right? So I see IH1, the input we get here, activation function, we get H1 to propagate out, right? So the 0.68 is this value. Then we will see the H2, right? Following the same way. So H2, first we get the input of H2. We also have two roots. One root is from I1, and the other root is from I2. So we can see is what? Is I1 multiply W2 to here, and I2 multiply W4 to here, right? So we can use this formula to calculate IH2, 0.68. Then what we will go H2 to next goes to the activation function, right? The sigmoid function, this value comes here, and we have a result of H2. So this H2 is here, and this will be propagated out from the neuron in the hidden layer. Then now we have this value and we have this value, we will calculate the O1 value, right? So let's first calculate the input of the O1. So how to calculate the input from O1? Yeah, so we can have a H1 multiply W5 and H2 multiply W6, right? So we can add them together. We did sum 0.8 hit O1. So this is the input to O1. But O1 also we have an activation function. So we go to the sigmoid function here, we get the result. So output of O1 is 0.69. And our expected output is 0.5, right? So the next step, we want to make the output to be as close as 0.5, the expected output, as possible. So that will be introduced in the next session about the backward propagation to optimize the W and B, right? So that's all for this session. Thank you very much. Bye-bye.